Now we'll move on to math. First, we'll take a look at averages. They're quite likely to give you a problem like this, where it says John takes a course and is told that 2 tests in the final will determine his grade. The final will be weighted double. If he's made an 88 and 86 on his first 2 tests, what does he have to make on the final to average 90 for the course? The trick to these questions is to remember that final is weighted double, so it's going to count twice. It's going to count as 2 tests. And that means you've got 4 test grades that you're looking at. You have to account for that final being weighted double when you set up your equation. Now we'll take a look at percentages. You've got to be very careful around percentages because they give you a problem like this. So they'll say, what's 1/4% of 500? Well, you just go 0.25 of 500 is 125. Nope. You misread that as 1/4, not 1/4%. That's actually 1/4 of 1%. So in decimals, it's 0.25%. Removing the percentage sign, it's 0.0025. So we want 0.0025 of 500, which is 1.25. Big difference. Be careful around percentages. They love to trap you around those. Just when you see a percentage sign, look very carefully at what you're looking for. Now, dealing with percentage change or change in percents, where you're manipulating percentages, you're going to have to look at this a little bit differently on the SAT than you're used to doing it on tests at school. You need to learn to work with percentages in decimals and to do your work on the percentage side. Rather than finding out what 25% of $400 is and then subtracting it, you want to learn to work on the percentage side. We'll show you why in a second. The key to attacking these problems is realizing you start with 100%. Your starting price is simply 100% of whatever it is. We represent that as 1.00. So if we're reducing the price 25%, we subtract 0.25 from 100%, 1.00. That gives us 0.75. We're looking for 75% of the price. Flip side, if we're increasing the price 25%, you're adding 25% to the price, so we add 0.25 to 1.00, and that gives us 1.25 of the price. We want 125% of the price. I realize you may be saying to yourself, well, why do I need to learn to do it this way? I'm comfortable doing it the other way. Well, there's a good reason. And the good reason is a problem like this. A car manufacturer increased the price of a car 30% in 1980 from its original price in 1975. If they increased the price 50% in 1985, how much did they increase the price in the 10 years? This is why you have to work on the percentage side. They don't give you a starting price here. You've got to do all your work on the percentage side. But since you know how to do it, it's pretty easy to do. Okay, they didn't give us a starting price, but that doesn't bother us because we know whatever it is, it's 100% of the original price. So we put down 100%, which is 1.00. Now we're going to increase the price 30%. So we want a 30% addition to that 1.00. So adding 0.3 to 1.00, we get 1.30, 130% of the price. Now if we multiply that by 100%, that's pretty easy multiplication. It gives us a new price of 1.30. And this is where it gets pretty tricky, because now they're going to have you do a second increase. We want a 50% increase to that new price of 1.30. A 50% increase, again, we add 0.50, 50%, to the 1.00 because we want 150% of this new price. Multiplying 1.50 times 1.3, we get our new price, which is now 1.95, 195% of that original price. But they're not through with you yet, because notice you have D and E as answer choices. Remember, they're looking for the total increase, and most of the time on this test, that's what they want, the total increase. So you're going to have to subtract the original 100% price out. We started at 100% of the price, we're now at 195% of the price. That's a 95% increase. So the correct answer is D. Now let's look at word problems. You want to remember that the numbers in word problems usually aren't very tough. What makes a word problem difficult are the words. So it makes sense to get the numbers out of the words. Look at it this way. If you leave the numbers in the words, you're playing their game. If you get them out so you can work with them and manipulate them, the ball's in your court. Let's look at one. Michael's made 40% of his first 15 shots. What does he have to average on the rest of his shot if he ends the game with a 50% average of 30 shots? Get the numbers out of the words. Let's look at what we have here. First of all, he's made 40% of his first 15 shots. 40% of 15 is 6. That tells us he's made 6 shots so far. What does he want to get to? Well, he wants to make 50% of the 30 shots he takes. So that's 15 shots. Okay, he's made 6. He wants to make 15. If we subtract, we find that he's got 9 more baskets to make. And how many shots does he have to do it in? Well, he's taken 15 shots. He's going to take 30. So he's got 15 more shots to take. And if we look at the average here, 9 of 15 is 60%. Taking a look at inequalities, they'll usually ask for 2 types. This first one we'll call a string out. It says that 3x plus 6 is greater than negative 15 but less than 30. Now your teachers at school may teach you to separate these and work it as 2 separate inequalities, but I'm going to suggest we want to keep things simple on the SAT. So let's keep it as one inequality. And remember that if you do something to one segment of it, you must do it to all segments. First we're going to isolate that 3x. So let's subtract 6 from each portion. Well, that'll give us negative 21 is less than 3x, which is less than 24. Now if we divide through by 3, we're left with x is greater than negative 7, but less than 8. This second feature of an inequality is actually more common. Actually, when you see inequalities on the SAT, your antenna needs to go up, and you need to start looking for a negative value. Because remember, if you multiply or divide by a negative value, it flips the inequality. For example, negative 5x plus 6 is less than 26. Subtracting 6, that gives us negative 5x is less than 20. When we divide by negative 5, it reverses the inequality. So you're left with x is greater than negative 4. Now we'll take a look at exponents. We're sure you're pretty familiar with your exponent rules, but we want to refresh your mind because there are a couple that have proved to be tripping points for students. Now rule number 1, a to the m equals a times itself m number of times. This one's pretty simple. It's just a times itself the appropriate number of times. Now notice I'm using a and I'm using m here. The SAT loves to give you variables other than x and y because they know you're used to seeing x and y. They like to give you variables like a and m and p and t, anything to bother you. Okay, rule number 2. A to the negative m equals 1 over a to the m. Anytime you have a negative exponent, that means there's an exponent in the denominator. Concomitantly, if you see an exponent in the denominator, it's illustrated with a negative exponent. Now number 3 is the most important exponent rule we're going to go over. And I know I didn't do anything to that. A to the m plus a to the n equals a to the m plus a to the n. This is frequently a tripping spot. Remember, if you add or subtract the same number or variable with different exponents, you can't do anything to the exponents. All you can do is factor a little bit. The reason for the confusion is rule number 4. A to the m times a to the n equals a to the m plus n. If you multiply the same number or variable with different exponents, you add the exponents. Now rule number 5, a to the m raised to the power of n is a to the m times n. The only time you multiply exponents is when you're raising a power to a power. And rule number 6, if we divide by exponents, you're subtracting. So a to the m divided by a to the n equals a to the m minus n. The SAT comes at you 2 ways on simultaneous equations. This first way is they'll give you simultaneous equations stacked up or side by side. Now you're used to solving these by substitution or elimination. On the SAT, it is not only far more efficient, but it's also going to get you the correct answer and avoid any rounding errors your calculator makes by you remembering to focus on the target. Look at what you're looking for. Determine what you want and see how you can manipulate the equations to get there. For instance, in this case, you're given that 2x plus y equals 19 and x plus 2y equals 9. Then what's the value of 3x plus 3y? Okay, we don't want what x is, we don't want what y is. We want what 3x plus 3y is. How can I get there? Well, I can either add the two equations. That works this time. If I add the two equations, I see that 3x plus 3y equals 28. Now, sometimes you may be subtracting equations, sometimes you may be adding them, but the key is focus on manipulating the equations so you can get to the target that you're looking for. The second way they'll address simultaneous equations is to embed them in word problems. Let's look at one. Alex is twice as old as Connie. Connie is 2 years younger than Janice. Their average age is 22. How old is Connie? Okay, the key here is, again, focus on what you're looking for, put everything in those terms, then set it up and solve it. In this case, we know that Alex is twice as old as Connie. And we know that Janice is 2 years older than Connie. Okay, their average age is 22, so we set that up, and now we simply substitute the values in. We get 2c, that's Alex, 2 plus c, that's Janice, and c is Connie. Cross multiplying, we see that their total age is 66. Subtracting 2 from both sides, we get 4c is 64, and we find out that Connie is 16. Let's take a look at scientific notation. Scientific notation is really pretty simple. Shouldn't be too much of a problem. Just remember you count the number of zeros to the right of the number. So 4 times 10 to the 5th is 400,000. 7 times 10 to the 4th is 70,000. Now if you're multiplying two terms that are represented in scientific notation, you're going to want to combine like terms. So if we've got 4 times 10 to the 6th times 7 times 10 to the 7th, combine like terms. So you're going to have 4 times 7, and you're multiplying the same number of variable with different exponents, so you add the exponents, so you get 10 to the 13th, which gives you 28 times 10 to the 13th. But remember, with scientific notation, you have to take it to one decimal place. And we're moving one number to the left, so that becomes 2.8 times 10 to the 14th. Intersecting lines from vertical angles, and vertical angles are equal. And remember that supplemental angles share a line and total 180 degrees. And now we'll take a look at functions. Now a function is simply a new rule that you're given. For instance, f of x equals x squared minus 6x plus 10. Let's also say that we're given g of x equals x plus 2. If I wanted f of 2, I simply substitute 2 in for x in every part of the equation. So I'd get f of 2 equals 2 squared minus 6 times 2 plus 10, which would be 4 minus 12 plus 10, giving me 2. Now remember, with a function, you simply substitute the value you're given. So f of 3, I would have put 3 in everywhere there's an x. F of 10, I would have put 10 in everywhere I see an x. It's simply a matter of following the rule and making the substitution they request. Now, let's look at a little tougher function problem. This is called a nested function. Using those same two equations, or those same two functions, they'll ask for f of g of 2. We solve this from the inside out. Let's first solve for g of 2. We substitute 2 in where there was an x. So g of 2 is 2 plus 2, or 4. Now we take that value. We've solved for g of 2 and seen that it's 4. We now substitute that 4 back into our original equation of f of x equals x squared minus 6x plus 10. Substituting the 4 in there, we see that we have 4 squared minus 6 times 4 plus 10, which is 16, minus 24 plus 10, which gives us 2. Now you'll see those traditional functions from time to time on the SAT. But what I can guarantee you will see 1 to 2 times per test are made-up functions. They're called made-up functions because they're characterized by goofy signs to denote the new rule that they're applying. These goofy signs can be asterisks, arrows, tildes, all kinds of goofy little signs. But you can't allow yourself to be distracted. Focus on what they're asking for and what the new rule is. Let's look at one. This made-up function gives us, for all integers a and b, let a arrow up b equals 7, of the values below which is greatest. Then we're given the choices. For number 1, a equals 4, b equals 72. Number 2, a equals 782, b equals 1086. And 3, a equals negative 14, b equals negative 17. Then we have our answer choices to choose from. The key here is to focus on the rule you're given. It says a arrow up b equals 7. Well, if I put a 4 in for a and a 72 in for b, what do I get? 7. If I put a 782 in for a and a 1086 in for b, what do I get? 7. Nothing changes that 7 on the right-hand side of the equation. Now, this is a goofy problem. This is one that's more of a puzzle than a math question. But it's easy points. Anything you put in for A and anything you put in for B comes up 7. So the correct answer here is D. They all have an equal value. Once you get and stay focused on the rule they're giving you, these problems aren't that tough, and they're in the difficult section, so it's like stealing points. Perimeter of a square is 4 times the side. You got 4 equal sides. The area of a square is side squared. The perimeter of a rectangle is 2 times the length plus 2 times the width. And the area of a rectangle is length times width. The area of a circle is pi r squared. And the circumference of a circle is 2 pi r, or pi times the diameter. Remember the pi times the diameter. That shows up more than you think on the SAT. The key to finding the area of a triangle lies in the base and the height. The height is the perpendicular distance from any side to the opposite angle. And the area of a triangle is base times height divided by 2. One way to remember that you're dividing it by 2 is to remember that a triangle is simply half of a rectangle. The volume of a cube is side cubed, hence the name. All volume really is area times the height, as we see in the case of a cylinder. The volume of a cylinder is pi r squared, the area of the circle at the top or the bottom, times the height.